Alright, so welcome to the first lesson of the second semester of Algebra 2. I cannot believe that we're here this quickly, but here we are. So I'm sorry I couldn't be there today. I have a dentist appointment, but I have recorded this video in advance for you guys. Now, if you don't learn well through a video, I would suggest writing an AAP pass right now to come see me during AAP sometime this week so that you can one-on-one with me about this topic, because it is a very bulky topic. Alright, so let's give ourselves a heading here. This is RAT1, simplifying rational expressions. Now the word rational, note that it has the word ratio in it. That means that we're dealing with a fraction. We're dealing with a fraction, and that's what this entire unit is going to be about. RAT stands for rational. So this entire unit is about fractions. The main idea here of this first lesson, the main idea is that we are going to be simplifying fractions by dividing the numerator and denominator, by their greatest common factor. So we're simplifying fractions. That's the main idea. We're simplifying fractions by dividing both the top and the bottom by some greatest common factor that they share. So for example, 8/12. We've done this part before. 8/12, we can see that both the top and bottom are divisible by 4. For example, 8 is 2 times 4, and 12 is 3 times 4. So because 8 is 2 times 4 and 12 is 3 times 4, that means both fractions, or both parts of the fraction, have a greatest common factor of 4, which we can cancel out because it's on both the top and the bottom. And we're left with 2/3. In other words, what I just did was I divided both the top and bottom by 4. 8 divided by 4 gives me 2. 12 divided by 4 gives me 3. We've done this before. And so this is my answer. What we're instead going to be doing that's new is this. If we're given a fraction with two trinomials like this, alright, if we're given something like this is a separate example. We're going to factor both of these. Now I know you know how to factor these, so I'm just going to skip ahead here. We're not going to do the cross puzzles. I know you know how to do the cross puzzles. What you get from doing both of these cross puzzles is on the top we have x minus 3 and x minus 1. And again, you get this by doing a cross puzzle on x squared minus 4 over x plus 3. You get x minus 3 and x minus 1 as the two factors. And on the bottom, if we do a cross puzzle with this, we get x minus 5 and x minus 1. I know you know how to do the cross puzzles, but for now I'm doing this for you so that we can see the main idea of this process. Now, why did we do that? Well, you can see that now we have a greatest common factor of x minus 1 on both the numerator and the denominator. So we can cancel it out. And we're left with x minus 3 over x minus 5 as our answer. So in other words, this whole rational expression simplifies to this, because we can cancel a greatest common factor of x minus 1. That's the main idea. It's factoring and then canceling. Alright, let's do another one. Alright, so here we have 5x times x squared plus 4x plus 3, all divided by x minus 6 and x squared minus 9. Now there are two pieces of factoring that we can do here. We have a cross puzzle on top because this is a trinomial. And on the bottom, x minus 6, that's already factored. We can't do anything with that. But x squared minus 9 is a difference of squares. So this we can factor with an x puzzle, or cross puzzle. And this we can factor with difference of squares. Now, if you're not caught up with difference of squares, I suggest you do some research. Look up a video of someone talking that isn't me, because I've taught this twice now. I am not going to reteach it a third time. So, when we do a cross puzzle here, we should get x plus 1 and x plus 3. Because again, the cross puzzle would have 3 on the top, 4 on the bottom, and from there we don't have to split the middle term because the coefficient here in front of the x squared is 1. So we get x plus 1 and x plus 3. And on the bottom we have this x minus 6 here, from here. And x squared minus 9 is a difference of squares. So we have x squared and then minus 9. So this is x squared and 3 squared. So we end up with x minus 3 and x plus 3, like this. The order in which you put these doesn't really matter, because in the end, the x plus 3 is going to get canceled anyways. So now, let's do that. Let's cancel this, and we're left with 5x, x plus 1, divided by x minus 6 times x minus 3, and that is our answer. We do not have to simplify this back out. However, you can if you want. You may see an answer on a test where it expects you to simplify this back out, but if it's not multiple choice where the answers are distributed and FOILed back out, then you can leave it like this. So usually you can leave it like this, and it's fine. Okay. Now the other new topic of this lesson is, when is x undefined? Now, this word undefined, we've seen it tossed around in a couple of different algebra classes, and the word undefined is usually associated with division by 0, and that's true here as well. It's where the denominator would equal 0. So, for example, let's take our example from above. We have 5x times x plus 1 times x plus 3 over x minus 6, x minus 3, x plus 3. Now notice that I'm using this part and not this part. That's very important, because this is just a factorization of the original problem. This part is after simplification. So you need to look at the original problem. You need to look at the original problem in order to figure out where x is undefined. So for this part, we have 3 places. We have 3 different places where x could equal 0. This is the same skill as when we were solving quadratics. Here, x minus 6, in order for this to equal 0, x would have to be positive 6, because 6 minus 6 would be equal 0. So in other words, if x is equal to 6, or if x were equal to 6, that means that this part would equal 0, and we would have 0 in the denominator. And that's not good. So from this factor being in the denominator, we know that x is not equal to positive 6. From this factor being in the denominator, we know that x is not equal to, well, what will make this 0? It would be positive 3. Because if we were to plug in a positive 3, the numerator would be fine. The denominator would not, because 3 minus 3 is equal to 0. And on the bottom here, in this last part, x plus 3, from that factor we know that x cannot be negative 3 either. That still holds even if these cancel. Even if these cancel, x still cannot be equal to negative 3, because if we were to plug negative 3 back into the original problem, you would see negative 3 squared would be positive 9, and 9 minus 9 would give me 0. So in other words, our answer is still 5x times x plus 1 over x minus 6 times x minus 3, where x is not equal to 6, 3, or negative 3. And this is the full answer. Now, sometimes you don't have to write this. When we actually use this for other things, we're going to assume that these values are not included. But for now, it's very important to point out that these values are not included. Especially when we work with functions, this is going to become very important. All right, so there are now 3 more problems that I would like you to do. And I'm going to be going through them, but after we pause for a moment. So here they are. For y minus 3, y plus 4, over y times y squared minus y minus 6. The second one is 2z, z plus 5, z squared plus 2z minus 8, all over z minus 1, z plus 5, z minus 2. And the last one is 4w squared minus 3wy times w plus y over 3y minus 4w times 5w plus y. Okay. So I'm going to pause, and I want you to work on these 2 for a bit, and then I'm going to unpause and go over these with you. This last one is a little bit tricky. It has a nuance that we haven't seen before, so we'll go over this one together. So take a moment, work on these on your own for about like 5 minutes or so, and then we're going to come back. Okay, so we're about to go over this. Okay, so for this first one, we only have one bit of factoring to do, and that's down here in the denominator. So let's do a cross puzzle here. Let's do a little bit of a cross puzzle here. I'm going to do this over here. I'm going to do this over here. So our cross puzzle has negative 1 on the bottom, negative 6 on top. Now the 2 numbers that multiply together to give me negative 6 and add together to give me negative 1 are negative 3 and positive 2. In either order, doesn't matter. So what that means is our 2 factors, because the coefficient here on y squared is 1, we don't have to split the middle term. So we get 4y, y minus 3, y plus 4, over y minus 3, y plus 2. That's where the 2 side numbers come in. And now, we can cancel 2 things. Not only can we cancel the y minus 3, we can also cancel the y's here out front. We can also cancel the y's here out front. And we're left with 4 times y plus 4 over y plus 2. Now, where is x undefined? Well, let's look at our factorization of the denominator. We have y here. Now, what do we plug in to make this equal 0? Well, it's just 0. If we were to plug in 0, then this y, and in other words this y, would become 0, and the whole denominator would become 0. So we can't plug in 0. Then we have y minus 3. Oh, this should be a y, sorry. This should be y. Let me just erase this. This should be y. Y minus 3 means that y cannot be equal to 3 either. We don't have to write it like that. We can write it like this. And y also cannot be equal to what would make this 0 as well. Y plus 2, that means y cannot be equal to negative 2 either. And if y is equal to one of these, then this has no meaning, because if we were to plug one of these numbers into this whole thing, one of these parts in the denominator would become 0, and we would get something divided by 0, which is no bueno. Alright, the second example. We have another cross puzzle. This time it's in the numerator here. So we have negative 8 on the bottom. No, sorry, whoa. Nope, sorry, my bad. Positive 2 on the bottom, negative 8 on top. There we go, much better. And we have the two numbers that multiply together to give -8 and add together to give +2 are +4 and -2 in either order. So again, the coefficient on z squared is 1, so we don't have to split the middle term. So we get 2z, z plus 5, z plus 4, and z minus 2. We got those from the side numbers of the cross puzzle. All of it over z minus 1, z plus 5, z minus 2. Now we can cancel two things. We can cancel the z minus 2's, and we can also cancel the z plus 5's. So that means we're left with 2z times z plus 4 over z minus 1. Now where is z not defined? So z cannot be equal to +1, -5, or +2. All right, now for this last one, we have two different variables. Now because of this, we don't actually have to worry about doing the places where variables can be undefined, because we can't make any assumptions about one particular variable, so it's very hard to say, oh, w can't be this, y can't be this, unless it's just like a w out front. Then of course w can't be 0. But typically with two variables, we don't do this part. So now, what kind of factoring can we do here? Well, there is one set of factoring that we can do here, and that's on this binomial here. We have a GCF with w's. We have a GCF of w, because both of these terms have one w in them. So in other words, we can pull out a w from 4w squared minus 3wy, and we get 4w minus 3y. So that's how we rewrite the first part. The rest cannot factor, so we are going to rewrite those as they are. And now we have this. So real quick, I'm going to highlight these two. This might ruin my highlighter because it's black, but still, I'm going to highlight these two. So these two are what we know as opposites. These two are opposites. What I mean by that is if we were to take 4w minus 3y and multiply it by -1, we would get 3y minus 4w. If you don't believe me, try it yourself. Distribute this out and you'll see how this is equal to 3y minus 4w. Therefore, if we were to take 4w minus 3y and divide it by 3y minus 4w, we would get -1. So we can cancel both of these out and reduce it to -1. It's not the same thing as canceling these out outright, because they're opposites. They're not the same thing, they're just opposites. So when we divide them, we can get -1. And so instead of getting w times w plus y in the top, we're going to get -w times w plus y on the top, divided by 5w plus y on the bottom. And that negative comes from what we get by dividing 4w minus 3y by 3y minus 4w. We divide both of these and we get -1 because they are opposites. And that -1 is right here with this negative sign in front of the w. And again, because we have two variables here, that's too many possibilities to rule out anything from, like, it's too many possibilities for us to say, oh, w can't be this and y can't be this. So we're just going to circle this, or box that. So yeah, with two variables, unless it's obvious, like a w out front or something like that, when you have, when the two parts have both a w and a y like this, you don't have to worry about, oh, w can't be this and y can't be this. They both have a y and a w, so we can't really eliminate anything. All right. Flip to the back, work on the sample problems.